Good day, ladies and gents. My name is Tabu, and welcome to my recap series. Now we are doing areas and distances. But just I just want us to recap on a few things. So, given the question, evaluate the following. Let's say evaluate. This is an LU. Hope you could see that. Following. Could try this on the side. Then see the answer. You done. Okay, let me write this properly. Uh, I might have made a huge mistake. Well, okay. Got the square part. I really need to have a glass of water now. Now it's pops. Oh. Yeah, 4n squared. Oh. Okay, so that means we would have 4n squared over 4 multiplied by n squared plus 2n plus 1 minus 3n squared plus 3n over 2. So that means we're going to have 4n to the fourth plus 8n to the third plus 4n squared all over 4. Let me see. 4n to the fourth, 8n to the third, 4n squared over 4 minus 6n squared plus 6n over 4. So we are going to have 4n to the fourth plus 8n to the third minus 2n to squared, n squared, minus 6n over 4. So we're going to have 2n to the fourth plus 4n cubed minus n squared minus 3n over 2. So that is what we have this moment in time. Yeah, it is what we have. So that's our solution to this problem. So now, what if you were given this as n approaches infinity? Three all over n, I over n all squared plus 1. Right? So what if you were given this? So basically you would have to start by simplifying this. So limit as n approaches infinity, and we'll have it's not equals to, then we'll have 3i squared all over n cubed plus 3 over n. Right. So we have limit as n approaches 0. So we're gonna have 3 over n cubed I squared plus 2 over n 1, which means as n approaches infinity, I'm gonna have 3 over n cubed okay, let's just erase this. We're gonna have n plus 1, 2n plus 1 all over 6, and plus 3 over n multiplied by n. Okay. So limit n approaches infinity, gonna have 3n n plus 1. Okay, let me just multiply these out. I have 2n squared plus 3n plus 1 6n cubed plus 3. So it's going to be limit as n approaches infinity, 2n cubed plus 3n squared plus n all over 2n cubed plus 3. So we're going to be having limit as n approaches infinity, 2n squared plus 3n plus 1 plus 3n squared. Wait, okay, this one I'll do separately. I need to see what the denominator is first. About 2n squared plus, 6n squared all over 2n squared. Limit as n approaches infinity, it will be 8n squared plus 3n plus 1 over 2n squared. So you will get multiplied by 1 over n squared by the highest power of the denominator. Then approaches infinity, we have 8 plus 3 over n plus 1 over n squared all over 2, which when we evaluate the limit, we'll have 8 over 2, which will have 4. So this whole question, and the one we just did of limits, comes to the whole idea of areas. And thus finding Raymond's sum, and finally understanding what integration is. So this looks beautiful. Let's go. So now stepping into the area. So the quite basic things that we need to know when you get into area. So area is defined as the space covered by a two-dimensional fixed boundary object. So that's like this, or this, or this, or this. So two-dimensional object with a fixed boundary, basically. So now, if we are given the following, right? If we're given this curve like this, that's a weird straight line. Given this curve, this curve is like the weirdest curve you could get. Okay, not bad. And this curve goes something like this. This curve is like this, and we are told to find the area under the curve. So what we would do initially is approximate. So by approximating, what do I mean? You'll assume you have an n number of rectangles within the curve, right? So something like this. It was a rectangle. Something like this. What a rectangle. Not a triangle. Like, yeah. Okay. So it's the triangle. Something like this. Basically, we'll be approximate. Yeah, this is a noisy rest. I'm a student. So we have these triangles, all with the same width, which is, let's say, delta x. Right. So we have 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So this is what I would assume and the area of under the curve to be. And use the basic knowledge that I have to find the area of the rectangle. So the width will be given by xb minus xa all over the number of rectangles. So let's say xb is here, xa is at the start, so like this one is xa. So the width will be given by a number of rectangles. Now, in regards to picking the height, we have to see our sample points. Okay. By referring to A, when I say now I'm referring to XA from that point, note that I'm saying my number of rectangles are minused by 1. So instead of it being 22, I'm saying 21. Right? So yeah, we could place A here, but it's gonna be XP only, so won't do us any good. So we need to pick our sample points, right? So either we use the left endpoints of our rectangles, the right endpoints of our rectangles, or the middle points of the rectangles. So now let's do an example of this, just to get the feel of it. So example says estimate the area under the curve y is equals to x squared from x is equals to 0 to x is equals to 4 using four rectangles and right endpoints as our sample points. Excuse me, let me just close the window a bit. So we have from 0 until 4, right? So sketching our graph is something like that. And something like that. Okay. We have this. This is our y-axis and this is our x-axis. And so this is being 1, and this is being 2, 3, and 4. 1, 2, 3, 4, 5. Okay. Since it's until 4, we'll need 16. So let's see something. 1, 2, 3, 4, 5, 7, 8, 9, 10. Right, and then we'll have something like this. So this being our x, this being our y, this being 0, the 0 point. So we have 1, 2, 3, 4, 5, 6, and so on, but we're ending at 4. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Yeah. So, yeah. So at 4.4, which goes up this line, we have this C1. Yeah, we have that. And then at point 0.4 we have that. At point 3 we have 9. At point 2 we have 4. Point 1 we have 1. And it goes something like this. Right? And they said we should use our right endpoints. So basically these points. Right? So to sketch rectangles, so rectangles be as follows. Don't do that. Yes. Okay. Assume it's at 9. Exactly at 9. And you have something like this. It's hard to do on a smooth screen. So these are rectangles, right? And we need to find the widths of these rectangles. So it's going to be b which is 4 xb minus 0 xa divided by a number of rectangles. So this is our width. Number of rectangles is going to be 4. Right, so in that case, what we're going to have is equals to 1. So our width is equals to 1 like this. This is 1. And this is equals to this, and this is equals to this, and this is equals to this. So width is the same everywhere. The difference is our height. And this is our y is equals to x squared curve. And using our right end sample point, we're gonna have this. So we sample points. And we're gonna have our height. then we're gonna have our widths, and this is gonna help us find our area. Okay, so my sample points in this case, right, end is 1, 2, 3, and 4. So my height is 1, it's 4, it's 9, and it's 16. And my width is the same, which is 1, 1, 1, 1. So my area, my estimated area, estimately be equals to length times breadth. So the first length times breadth is the area of a rectangle is length times breadth, right? So my first one, or length times width, or height times width, better. My first one will be 1 times 1 plus my second one will be 1 times 4. Remember, the 1 is the width, no? And my third one will be 1 times 9. Fourth one will be 1 times 16. So my area will be 1 plus 4 plus 9 plus 16. My estimated area should thus equal to, this is 10, this is 20, 30 units squared. So this is the first question. It's interesting, man. This topic it takes a lot of work, but it's like easy to understand because it's based on what we've been doing for grade R, I think. Joking. That was a joke. Grade R, wow. I must have been in a high level school. The big thing was grade R. Yeah, I think we did. Estimate the area under the curve of y is equals to x squared from x is equals to 0 to x is equals to 1 using 5 rectangles. And left endpoints. You will pause the video and try this on your own. So I'm going to start by calculating the width, which is equals to 1 minus 0 divided by 5. divided by 5. So it's going to be 1 over 5 or 0.2. Yeah. So let's draw a rectangle, our Cartesian plane. This one should be a bit smaller, but I'm gonna increase it so you can see what's going on. Why are you doing that? Why are you doing that? Someone would say it doesn't matter. So there's something like this. So y, x, right? So I'm gonna divide this into 1 over 5, 2 over 5, 3 over 5, over 5, 1, which is 5 over 5, right? And then x squared, we're just gonna do it with the one part, so this scale should be the same on the other side. Over 5 over 5, 1. So something like this. And be using left endpoints, that means the first rectangle will be on the Cartesian plane like this. And then the second one will be as follows. Then the third one will be as follows. The fourth one, this is 1, 2, 3. Fourth one will be as follows. The fifth one will be as follows. So all the widths are 1.5. So bring a bit of a table again. So it's width, sample points, height, something like this. So this will be a sample point column. Not column, row, or sample point row. Sample, this will be our height row, and this will be our width row. Okay, so these are sample points. Sample points. So first sample point is 0. Our second one is going to be 1/5. Third one is going to be 2/5. Fourth one is going to be 3/5. Fifth one, lastly, is going to be 4/5. And then we're going to have our width, which is the same everywhere: 1/5, 1/5, 1/5, 1/5, 1/5. Right? We're gonna have our height, which our first height is 0, because 0 squared is still 0. Our second height is 1/25. Our third height is 4/25. Our fourth height is 9/25. 16/25. So our estimate area using left endpoints will be given by 0 times 0, 0. 1/5 times 1/25. That's 1/5 times 4/5. 1/5 times 9/5. 1/5 times 16/5. So it'll be this. So it'll be 0 plus 1/125 plus 4/25, 9/25, 16/25, right? So it's only 4/125 plus 9/125 plus 16/125. So basically, we still have our 30 on top, if I'm not mistaken. Yeah, yep, our 30 over 125, which is estimately equals to 6/25. So this is the second problem. In the third problem now, and fourth problem. Okay, we're just doing our last problem now and then done for the day. Problem number 3. Problem number 3 says estimate the area under the curve of y is equals to x squared. Don't get tired of x squared. This is a good teaching platform. From x is equals to 0 to x is equals to 7 using 6 rectangles and a right and points. That's our A. Okay. Yeah. That's our should have just said end using right endpoints. So the width will be given by 7 minus 0 over 6. So width will be 7 over 6. And so a function will look as follows. So here we have 7 over 6, and we have 14 over 6, then we have 21 over 6, and we have 28 over 6, and we have 35 over 6. Then lastly we have 7, which is 42 over 6. Label. Mr. Mahon. So we're going to actually put the same scale, but we don't really put the same scale. I'm just going to sketch here, right, the heights and everything. We're going to figure it out later, because it's going to be something else. Like this, something like this. It's a beautiful curve. And they said we should use right hand points, so it's something like this. Two-dimensional. He did it, but he was shy. You mean has always been shy? Always felt less than. Now I'm communicating a story of an individual I used to know. So this is this. And our last rectangle is like this. Okay, so we have that. And then our little nyana table, the nyana. Something like this. Okay, then we have 1, 2, 3, 4, 5, 6 sample points. Okay, let's just do this. 2, 3, 1, 2, 3, 4, 5, 6. Sample points, width, height. It's quite easy since we're using wide sample points. It's quite easy to 7/6, 14/6, 21/6. Since we use 28/6, since we're using wide endpoints, it's quite easy to actually figure out the 35/6, 7. Then we have our width, which is 7/6, right? So 7/6, 7/6, 7/6, 7/6, 7/6, 7/6. Right, so square these. From the squared function, we get 49/36. Right, and then if we square 14, we get 196/36. If we square 21, we get 441/36. If we square 28, we get 784 all over 36. And if we square 35, get 1225 all over 36. If we square 7, we get 49. How weird. So the estimated area will be as follows. We'll get 7/6 times 49/36 plus 14/6 times 196/36 plus, okay, it's not 14/6, it's 7/6 because we're still using the width. Yeah, I need a glass of water. Then we get 7/6 times 441/36 plus 7/6 times 784/36 and 7/6 times 1225 over 36, 7 over 6, 49. So, estimated area, I'm gonna just punch all of these in a calculator. So, we're gonna get 7 over 6 times 49 over 36. Seven. Let's not do this. 7 over 6 times 49 over 36 plus 196 over 36 plus 441 over 36 plus 784 over 36 plus 1225 over 36 plus 49. So answer is going to be approximately 144.50 units squared. Thank you guys for watching. Thank God for blessing you. And yeah, let's go grab a cup of water. I saw my attention span is off.